everybody, so 1.9 patterns, equations, and graphs. It's the last one before we have our test. Yahoo, and then we get to move on to some super fun solving equations and crunching numbers. Your essential question for today, how can you represent patterns using tables, equations, and graphs? So get that written down and we'll keep moving. Warm up. You don't have to write this down, I just want you to think through it. The table below shows the relationship between the number of kites in an arrangement and the total number of ribbons on the kite's tails. Describe the pattern in the table. How many kites could you make with 275 ribbons? Well, what do you see? 1 kite is 5, 2 is 10, 3 is 15, 4 is 20. What's the pattern there? Yeah, it's multiplying by 5. So therefore, how many kites could you make with 275? Well, what times 5 gives you that? To solve that, I'm going to go backwards, divide it, and I get 55. Would you agree? If you don't, go back and figure out why that is the way to do it. All right, this one I want to go in your notes. So what should you be writing down as you're figuring out, okay, what do I write? You should be writing identify solutions of a two-variable equation. Write that part down, and then actually write this question down. Is 310 a solution for the equation of y equals 4x? Well, is it? Yes or no? If you're thinking, B, I don't know how to figure that one out. Well, here's what we've got. The 3 is your x coordinate, and your 10 is your y. So here's my x, here's my y. What am I going to do to figure it out? Well, they tell me 4 x's equals the y. So I'm going to take this 3 and I'm just going to plug it in. 4 times 3. What does that give me? It gives me 12. Okay, so this says 10. So therefore, is 3 a solution of that to give you 10? And the answer is no, it's not. How about this one? You can write this one down if you want to. Is 520 a solution of that same equation? Well, this right here means 4 x's, 4 times. If there's no symbol in there, it means times. So 4 times 5, we're going to fill that in. 4 times 5, does that give me 20? Yes. So my explanation is, yes, it works because 4 times 5 equals 20, and that's what this said. All right, so you're going to do some of those today. It's really important. Can you figure out if an ordered pair fits on a line or fits into your equation? Next one. Would you write down using a table, an equation, and a graph? All right. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. That's really important. 2 years before Carrie. So we've got to figure out which way are we going. I look over here. We're going to use a table, an equation, and a graph. So I already drew my little T-chart for a table. I personally like to do my tables up and down. The book will oftentimes write them right to left because it takes up less paper. I like up and down because I see the pattern better. It works. It organizes better in my brain. Either way, it's fine though. So here's what I've got. Carrie's age is down here, and Kim's age is up here. So this is my x. Here is my y. So over in my over here, I'm going to write x and y, and I'm writing on my laptop, and sometimes it gets a little bit touchy. So here's my x. Here's my y. And kind of that. So that's my y. And so let's kind of figure that through. Both Carrie and her sister Kim were born on October 25th. Kim was born 2 years before Carrie. So who is older? Kim is older. So X is Carrie. Just going to write that down. And this is Kim. So if Carrie is 1 year old, Kim was born 2 years before, Kim is 3. If Carrie was 2, Kim is going to be 4. This is a lot of your families. If Carrie was, I'm going to skip some, and if she was 10, Kim is 12. Exactly. So that gave me, I've got a little chart here. Well then, if Carrie is X, Kim, what do I do to get there? Well, it's whatever Carrie is plus 2. That's my equation. And we're going to do a ton of pattern stuff like this, writing equations, which is great fun, and that will come further on in the year. Then we're also going to graph that. So I can just go back to here. When Carrie was 1, Kim was 3. So I go over 1, up 3. When Carrie was 2, Kim was 4. When Carrie was 10, does that fit on there? Yes. And when you do that, you should hopefully get something, hey, right there. I've got a nice little line that fits in there. I didn't draw it exactly perfectly, but there it is. You can see that anywhere along this, so at 6, when Carrie's 6, then Kim is 8, so on and so forth. So we start with a problem. You might say, this one is so easy. Yes, but we're going to start with the easy ones so that we can move on and continue and get to the tough ones later. Last one, extending a pattern. Oh, I love patterns. The table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in a figure with 8 blue tiles? Well, this first one has 1, and how many tiles are there? 9. Got it. So this, you could quick draw that picture. Draw this chart for sure. After 2, how many does it have? You might see the pattern right away, or you might need to count. I'm going to tell you it's 18. 3 is 27. What's the pattern? You do X times 3. Could the 3 go after the X? You bet. Of course it could. But we generally just write the 3, the coefficient in the front. So therefore, the question is asking you 8 blue tiles. 8. What does it give you? Ooh. What's my mistake? What did I make a mistake? I totally did. You're thinking, Beef, what the heck are you doing? This shouldn't have been a 3. What should it have been? Yep, it should have been a 9. That's why you never, ever write in pen. 9. 8 times 9. 72. 72. So sorry about that, but it's good. When you start thinking, I think she made a mistake, then you either tell me or you wait and I'll catch my own mistake, but I'm not going to go back and make the video. So that's what we did for today. Hope you're having a great day, and I will see you tomorrow.